Subscribe for more space. Subscribe for more space.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff of the Falcon 9 to the space station on the first commercial launch from Kennedy Space Center's historic Pad 39A.
Pad operations on Pad Net A.
Copy, Wilco.
Stage 1 propulsion nominal.
Subscribe for more space. Subscribe for more space.
The sun, the heart of our solar system. It's as familiar as anything we know. Although the sun has been studied for millennia, it still holds unsolved mysteries about its effects on our daily lives. To better understand the sun, NASA is preparing to launch a spacecraft called the Parker Solar Probe. It will lift off from Cape Canaveral Air Force Station near the agency's Kennedy Space Center, located in Florida. It's a mission of unprecedented opportunities that could revolutionize our understanding of our star and the outer layer of the sun's atmosphere, the corona.
Going into the sun's corona for the first time, going up close and personal with our star to be able to answer some of the mysteries that live in this coronal region. Why is the sun's corona hotter than the surface of the sun? Why is there a solar wind? Why does this atmosphere, this corona, become so energized that it can move away from the sun at supersonic speeds and bathe all of the planets?
Now that the Parker Solar Probe has arrived, it's time to get it ready to launch at the Astrotech Spacecraft Processing Facility.
Today's an exciting day on the Space Coast. Over at Astrotech, we'll ready their spacecraft for launch. That'll include any final assembly, including the assembly of the critical heat shield. We're going to be 24/7 helping the spacecraft get what they need to get ready for launch.
The Parker Solar Probe will be the first mission to travel through the searing heat of the sun's corona. Traveling this close is only possible because of the spacecraft's protective heat shield, where temperatures on the spacecraft reach 2,500 degrees Fahrenheit.
So Parker Solar Probe is actually going and touching the sun. The previous missions have been really important for solar science as we study from afar. And we can learn a lot from studying from afar. But Parker Solar Probe is actually going and touching, almost kissing the sun. So we can learn so much more.
And to do that, it will need to go faster than any other spacecraft in history.
Parker Solar Probe will be the fastest human-made object ever. We are traveling at an unbelievable 430,000 miles per hour.
That's why, for the first time ever, NASA's Launch Services Program selected the United Launch Alliance Delta IV Heavy rocket.
Delta IV Heavy was selected for NASA Parker Solar Probe program because of the extreme velocity required to meet the mission objectives in orbit around the sun.
Going out and seeing the Delta IV Heavy on the pad is a truly awe-inspiring experience. Just seeing that amount of raw power right in front of you is just incredible. 3 boosters, our second stage, and then we have a third stage. We're a tiny little spacecraft. We look like a little hood ornament on the top of the Delta IV.
Get ready to watch this historic mission lighting up the Space Coast as it thunders into the sky to get up close and personal with the sun.
T-3. Engine start. 2,
1.
The Moon. It's our nearest neighbor in space, and data we gather from its features can tell us a lot about the rest of our solar system. And through the eyes of the LRO spacecraft, we can explore the lunar surface in all new ways, in fascinating detail. Our tour begins on the western border, where the near side of the Moon meets the far side. The enormous feature is a lunar crater, and it's known as the Oriental Basin. Here, LRO's terrain map combines with surface gravity measurements from the Grail mission. This data reveals structure in the lunar crust beneath the surface, giving us a window into the geologic features of the Moon's interior. Our next location receives little direct sunlight and has some of the coldest recorded temperatures in the solar system, the South Pole. The highlighted spots signify potential water ice based on temperature readings from LRO's diviner instrument and reflectance from its laser altimeter Lola. Lola also allows us to peer into the darkness of Shackleton Crater by bringing us this digital elevation model. It's 21 kilometers wide and 4 kilometers deep, but it pales in comparison to the largest known impact crater in the Earth-Moon system, the South Pole Aitken Basin. Sitting on the far side, it's 2,500 kilometers across and 13 kilometers deep. We don't yet know exactly how old the basin is, but it was first seen in the 1960s by spacecraft flying around the far side. As much as we use LRO data to investigate areas we can't see from Earth, we also probe familiar territory on the lunar near side to bring back images with an all-new level of detail. This is Tycho Crater. It's around 100 million years old. Here, the Lunar Reconnaissance Orbiter camera captures the central peak with a 100-meter wide boulder at the summit, the origins of which are still a mystery. Continuing across the Moon's near side, we will arrive in an area ripe for future exploration due to the diversity of impact and volcanic materials. It features a prominent crater so bright it's not only visible through telescopes, but also to the naked eye. Welcome to the Aristarchus Plateau. Here, infrared shows the mineral pyroxene in orange and a splash of plagioclase in blue from Aristarchus crater. This region can tell us a lot about the rich volcanic history of the Moon. As much as we study the Moon looking for sites to visit, we also look back at places we've already been. This is because the new data that LRO is gathering helps us reinterpret the geology of familiar places, giving scientists a better understanding of the sequence of events in early lunar history. Here, we descend to the Apollo 17 landing site in the Taurus-Littrow Valley, which is deeper than the Grand Canyon. The path the astronauts took over the course of 3 days is shown. The Lunar Reconnaissance Orbiter camera is even able to capture a view of the bottom half of the Apollo 17 lunar lander, which still sits on the surface, as well as the rover vehicle. These images help preserve our accomplishment of human exploration on the Moon's surface. Moving onward, we make our way to our final destination. This location contains regions that exist in permanent shadow, as well as ones that bask in nearly perpetual light. It's the North Pole. Detailed terrain measurements by Lola allow scientists to model sunlight and shadow at the poles over decades and centuries. Sunlit peaks and crater rims here may be ideal locations for generating solar power for future expeditions to the Moon. This updated visualization of the lunar landscape stands as a testament to the functionality and abilities of the Lunar Reconnaissance Orbiter spacecraft. And as the mission continues to gather data, it will provide us with many more opportunities to take a tour of our Moon.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit, and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
Our planet is the setting for dazzling and interconnected webs of energy, physical phenomena, and life. Amazing to behold from close up, and hypnotic when seen from above. From space, the fleet of Earth-observing satellites operated by NASA and its partners illuminate the links between these systems. Temperatures on the planet affect all of them, which means each one is impacted by a warming climate. During 2020, global temperatures matched the warmest year we've measured, and we experienced the most active hurricane season ever recorded, with many storms quickly intensifying, likely as a result of warmer seas. Heat in the oceans is like fuel that powers these massive storms. But incredibly, dust swept up from northern Africa actually plays a critical role in the formation of hurricanes. It's also a key source of fertilization for the Amazon rainforest. Due to climate change, dust plumes are expected to decline, and then so will their impacts on vegetation and ocean away. Our satellites and field research allow us to pay close attention to the Amazon rainforest and other vegetation across the world, helping us track how fires, deforestation, and disasters affect the world's plant life. We can also study how those vegetation changes, in turn, impact air quality, waterways, and the climate. That same science helps the world's farmers boost productivity and deal with extreme weather, including drought, early freezes, and heavy spring rains. The observations can also help track some unwanted byproducts of food production. Fertilizers used in farming contain high amounts of nutrients to help crops grow, but those same nutrients can cause sometimes dangerous blooms of algae in waterways, which can affect local economies, recreation, fishing, and human health. They're often so large, they're easily viewed from space. Clean water and clean air are two cornerstones for maintaining healthy people and wildlife. Satellite data and NASA funding help map how animal migrations are affected by water sources, as well as light pollution and habitat loss, and also helps find solutions. The view from space is especially important in the Arctic and Antarctic, where animal habitats are rapidly changing due to climate change. And so is the ice itself, with Greenland and Antarctica losing enough ice in just 16 years to raise sea level by ½ an inch globally. We can also measure snow and ice farther from the poles, such as vital snowpacks in the Sierra Nevada and Rockies, and in the Himalayas, where rapidly draining glacial lakes can cause sudden and dangerous bursts of water downstream. Earth's climate is changing, and with it has come a new intensity to weather events and hazards that can lead to disasters, including floods, fires, hurricanes, and heat waves. As disasters become more frequent and intense, NASA will use its satellites and resources to study the effects of climate change on natural systems, and to connect people to technology that can build a more resilient world.
Sprites, I saw them on a documentary once, and I kind of became fascinated with them. I've been trying to capture them for a while, so it's kind of all snowballed into a semi-obsession.
Whoa! Whoa! I saw that one too.
I saw that one.
You saw that red one?
Yeah.
I can't wait to look at that one again.
My name's Paul Smith, and I'm a sprite chaser, which means I like to photograph the night sky and sprites in particular. They look like, to the naked eye, you would probably see them as flashes above thunderstorms, and then the camera picks up more of the colors. Nice red, orange, sometimes purple colors.
I would say the region of space about the thunderstorms is almost like an electrical zoo. We have these collection of electrical activity. We have blue jets, gigantic jets, trolls, halos. It's almost like an electric fairy tale. Sprites is just one of many. Collectively, we call these transient luminous events. Sprites are like snowflakes. They come in various shapes and sizes, so we call them angel sprites, carrot sprites, column sprites. They're just beautiful to look at, and just the fact that no sprite is identical to the other is good enough reason to study them and look at them all day long. You're never going to get bored. So sprites are very large-scale events. Their width is usually up to 5 to 10 kilometers, and their vertical extent is about 40 or 50 kilometers. You can almost fit a small town in there. Because these sprites are very large-scale events, they change the atmospheric composition, and we don't know the extent of this effect. So it's important to study them in the long run.
It's just a real cool thing to be able to shoot and see these things that nobody else is really getting on a regular basis.
I saw their phenomenal images, and I wanted to work with them and leverage their images and data collection. And it sparked this idea in my head: what if I created a citizen science project that I can connect the public with the scientific community so we can further our understanding together? With this new citizen science project, our goal is to create the first ever comprehensive database of sprites. I'm very excited about this. I know there are a lot of people out there who are naturally chasing sprites, so I'm asking all sprite chasers to submit their images to us. It's like a puzzle. They provide one piece, we provide the other, and we solve it together.
With this citizen science project, I'm just really excited to think that finally we'll have a connection, because I've been getting these sprites for so long, and I got a bunch sitting on my hard drive that nobody's really dissected or looked at, so I think this will be a good bridge for that. So there's a chance for storms and sprites, so let's get to it.
I've been studying sprites for 15 years and I have not seen them in person. I am super excited about the opportunity to go chasing with Paul. I haven't met him before and I'm going to be meeting him soon, so we're going to go capture some sprites.
Hello.
Hi, Paul. Hi. It's so nice to meet you. How are you?
You too. I'm doing great. Awesome.
Let's have a fist bump. So, what's our plan today? Where are we heading?
Well, we got some storms over in Arkansas and Mississippi that will be in range if we head down to southeast Oklahoma.
Okay, let's go sprite chasing.
Let's go. So the best places to catch sprites are where you've got big lightning strikes. We're heading to a lake in a dark sky area of southeast Oklahoma.
So when you look at the radar, we are mostly looking for those regions that have red cells, and the system was evolving to be able to form some powerful flashes, which we need for the sprites tonight. So it's looking good. Hey Paul, so what other tips you have for sprite chasing?
I always try to look for really dark skies. Maybe at first look on Google Maps and just find areas without any development nearby.
In a quarter mile, keep left at the fork. Follow signs for Daisy.
Okay, yeah, it looks pretty open here.
Yeah, that's the direction we're looking. So.
Right, perfect.
Where the storm was on the map, I just lined us up on Google Earth to like a landmark. I could see this point of the bridge here.
So yeah, we are right now here in Oklahoma, but the storm we are looking at is over Mississippi-Alabama state border, and that's pretty far out. We're talking about 375 miles, so it's pretty far out. When I look at the screen, I'm pretty much scanning the horizon here because the storms are pretty far out, and I'll be able to just see the lightning flash the top of the cloud tops, pretty much that light, and then that's my clue to trigger. And that's when I press the button and I don't see the sprite until I actually replay that little capture. And I'm hoping that I actually captured something.
I mean, I'm kind of thinking, because if I don't see something, oh, there was a sprite.
Seriously? And then the moment I just turned my head, seriously?
There was a sprite, guys, yeah.
Let's see.
I hope I caught it in
Oh
time.
my gosh. Yes! We had one. Oh my God, that's awesome. And that was actually pretty close.
Pretty close.
High fives, high fives. We did it. Oh, perfect. I think we got one. Awesome. And I think that was a column sprite. It's right there. We actually captured sprites. I keep replaying this. This is amazing. Yeah, that's why now I understand why you don't want to leave. Once you have one capture, this is all what science is about. It's just this excitement and trying to understand how they're formed and what makes them look the way they are. It's just amazing and a highlight of my career.
This citizen science project, I think it's going to be our best bet for figuring out actually what's going on with these sprites. And that's exciting to think that might happen in my lifetime. And if it doesn't, I'd be pretty disappointed.
SWAT is the Surface Water and Ocean Topography Satellite. It's an international satellite that's going to give us this complete view of the surface water here on Earth, what's happening in the lakes, reservoirs, rivers, and also in the ocean. It'll tell us about how sea level is rising along coastlines and in the open ocean, and really give us a good understanding of how surface water is moving about the Earth.
Our goal is to provide data, forecasts, watches, and warnings at some key locations like the Willamette River in Portland, which is a major U.S. city that historically has seen some catastrophic floods. The better quality of the data that we have that feeds into our models, the better the forecasts are going to be, the more time that people will have to protect themselves and their property and ultimately our communities. A tool like SWAT is going to help us with making these really difficult projections and predictions for the future.
This is one of many reservoirs here in the Willamette Valley in Oregon. It is a human-made lake. It is a reservoir operated by the Army Corps of Engineers. The water managers here, they use weather prediction, they use hydrologic models, and the hope is that data like SWAT might be incorporated into those predictions to help them better understand this water body's filling and we don't want to overtop the dams, might want to start letting water out really quickly. They have to make a lot of complicated decisions. When you get a big storm event, we want to keep the communities safe in the best way that we can. So how do we best manage operation of these reservoirs in terms of putting water out downstream to prevent flooding at a larger scale?
In lots of states, there are, hundreds, thousands of reservoirs, and many of those reservoirs don't have automated gauging available. And so these agencies have to kind of estimate how much water is in them and how that's changing. And with SWAT, they can just monitor that directly from space.
For us in Alaska, we have many, many rivers, and only a few of them are measured, or as we say, gauged. If we have data on when flooding is occurring or might occur, we can get crews out there to look at the bridge to make sure that the bridge and the associated roadway are still safe. If we can start collecting data on all rivers above a certain size remotely from satellites, it really opens up the amount of rivers that we can help understand what happens when they flood or how they flood. And that really improves our ability to manage our infrastructure and to design new infrastructure. That is where SWAT will really make a big difference.
One of the partners we're working with is the Department of Defense, and they're trying to fill gaps in the data that they have along the coastlines. Our military is obviously very concerned about what's happening on global scales, and they have installations across the globe. So SWAT will potentially provide an opportunity to fill in some of those gaps, allow them to make the impact assessments that they need for sea level rise in their facilities. So trying to understand and give them the information they need to plan for and then potentially adapt to these changes is really critically important.
Coastal wetlands like the Mississippi River Delta are extremely important because it acts as a buffer between us and the threatening ocean. With SWAT, because of its high spatial resolution, we'll be able to resolve water surface elevation right at the coast. So this is quite important because as sea level rises, the ocean will migrate into the land, bringing more salt into the land. So it threatens the infrastructure, the biodiversity in the wetlands along the coast. Hopefully, the types of models that we're producing can support how they decide to manage the river delta. And SWAT on its own will allow us to upscale these types of studies to the world.
Yeah, I'm really excited about the new information we'll get from SWAT and how we can start to couple it to some of the needs that we see, both at the coastal interface and also on land. I think we can potentially see some immediate impact once SWAT's launched in these communities.
This is Bennu, one of Earth's closest planetary neighbors. An asteroid roughly the height of a skyscraper, a remnant from the dawn of the solar system made of carbon-rich rocks and boulders. And since late 2018, the place that NASA's OSIRIS-REx mission has called home. When OSIRIS-REx arrived, it began wrapping Bennu in a complex web of observations, starting with a preliminary survey of its size, shape, mass, and spin. On New Year's Eve, OSIRIS-REx was captured into orbit by Bennu's minuscule gravity, making it the smallest world ever to be orbited by a spacecraft. In early 2019, it broke orbit to conduct a detailed survey. A series of sweeping passes allowed OSIRIS-REx to study geological features at different latitudes and times of day, enabling stereo imaging and landmark-based navigation. During the detailed survey, OSIRIS-REx globally mapped Bennu at only 5 centimeters per pixel, the highest resolution of any planetary body, including Earth. On June 12th, the spacecraft entered a new orbit at an altitude of just 680 meters, setting another record and establishing a home orbit for the remainder of the mission. In September, it began reconnaissance on 4 candidate sample collection sites, potential locations on Bennu to touch down and collect a sample later in the mission. OSIRIS-REx concluded its first year at Bennu back in orbit, circling the asteroid's terminator, or boundary between day and night. Here, outside forces acting on the spacecraft are balanced, allowing it to orbit within the same plane over time. Reconnaissance resumed in early 2020 with close flyovers of the primary sample collection site Nightingale and the backup site Osprey. In mid-April, OSIRIS-REx performed the first of 2 rehearsals prior to sample collection. It navigated to a predetermined checkpoint about 125 meters above Bennu, then descended to within 65 meters before backing away. After the checkpoint rehearsal, OSIRIS-REx flew one final reconnaissance sortie over Site Osprey. Then it made a series of high-altitude maneuvers while rebooting its onboard processor and preparing for its second rehearsal of the sample collection event. On August 11th, OSIRIS-REx departed its home orbit and made a 4-hour traverse to Bennu's northern hemisphere, retracing its earlier path. After performing the checkpoint engine burn to begin its descent, it made a second engine burn called Match Point to match Bennu's rotation before backing away at an altitude of approximately 40 meters. Now, the most crucial moment of the mission had arrived. On October 20th, 2020, at approximately 11:30 a.m. Mountain Time, the spacecraft departed orbit. A few hours before, mission controllers on Earth had sent the commands for the Touch and Go Sample Collection Maneuver, or TAG. As they watched with anticipation, OSIRIS-REx steered itself to sample site Nightingale, maneuvering toward the small crater at the walking pace of a spider. At 4:11 p.m., the mission received confirmation. OSIRIS-REx had touched down and collected its sample. Following TAG, the spacecraft drifted to a safe distance away from Bennu. By the end of October, mission controllers determined that it had exceeded its goal of collecting 60 grams of asteroid material. They directed it to stow the sample in preparation for return to Earth. Before departing Bennu, OSIRIS-REx was given one final task. On April 7th, it flew over Site Nightingale to observe how the sample collection event had changed the surface. And with that, OSIRIS-REx had recorded its mark on Bennu and spun the last strand of its web.
Subscribe for more space.